Hello guys, this is session 1 that we will do in our flipped class of decision mathematics, where I will try to explain you in as most detailed way as possible every single thing out of the syllabus of decision mathematics, and then you will have 2 days before extra classes in further mathematics in FP2 that you can come to me at any time and we can clarify some things that you either didn't understand or you couldn't get an answer for, or so on. We will start with section or unit 1 from chapter 1. The book that you have been given, this book covers most of the topics of decision mathematics 1, but it also have some topics that are not in the syllabus. But I will guide you through in a detailed way so we will know what to know for the exam, shall you decide to take it. The first chapter and first unit that is required is about the algorithms. There are 6 objectives, but you have to be careful because this one is not there. Determining the order of an algorithm is in the book, but is not included in the syllabus. But instead of that, in the syllabus is something from the old book that is a binary search. But again, I will provide enough information and enough practice problems that you will be able to do it. So what we will focus today on are these 2 objectives, and those are the algorithms given by words or in words and algorithms given by flowcharts that you need to be able to follow and analyze. All right. So when you think about it, those of you who are starting or who are taking the computer science classes, they already know what the algorithm is. The algorithm is a set of the instructions that give you the step-by-step directions how to achieve some goal. It doesn't have to be related to computer science, obviously. You can find algorithms in mathematics, but also in your daily life. The ones that we will do in decision mathematics are not really difficult, but they provide the insights how the tools are developed by the computer programmers for the softwares that are making our lives easier oftentimes. But as I said, algorithms you can find in daily life as well, such as when you are cooking, every single recipe is an algorithm. Or when you are giving the directions, then you also providing the algorithm for the person that you're navigating, because you are giving them step-by-step instructions how to reach their goal, how to reach their destination. But obviously there are the many algorithms in computer programs and also mathematical algorithms, how to add fractions or how to divide fractions, or many other algorithms, for example, how to solve quadratic equations. As I said at the beginning, the algorithms that we will discuss will be in 2 parts or in 2 groups. Algorithms given by words or in words, and algorithms given by flowcharts. So when you look at the first example that we're going to do, this algorithm called happy has 4 steps. We need to write any integer down and follow every single step, and we will see if we will get the answer 1. In that case the number will be happy, called happy, or if not, then it will be unhappy. So for example, when we going to talk about number 70, so square its digits and find the sum of the square. 7 squared plus 0 squared is 49. And then you repeat the same steps. So 4 squared plus 9 squared would be 97. Then we have 97, so 9 squared plus 7 squared, what is 130. Then 1 squared plus 3 squared plus 0 squared is 10. And then 1 squared plus 0 squared is 1. And that means it's fine, it's finished. Then we can say 70 is really happy based on this definition. If we're going to do number 4, so 4 squared would be 16. And then I repeat the second step, plus 6 squared, what is 37? So 3 squared plus 7 squared would be 58, and 5 squared plus 8 squared is 89, and a squared plus 9 squared would be 145, and then I have 1 squared plus 4 squared plus 5 squared, 25, 26, that would be 42, and keep going, and then we get 20, and 2 squared plus 0 squared is 4 again, and that's the same as what we started with, so we are in the cycle, and that's why we can say number 4 is unhappy, based on the definition given in this example. Okay, so this is just to show you that obviously we have some set of instructions, and then you follow them step by step. You cannot skip the step, you cannot repeat the step, you just have to follow whatever the algorithms say. The second example, there is a multiplication of two numbers. I will try to create more space and make the text little smaller. So what we have in here, if you're going to read step by step, we need to make the table with two columns. So I'm going to make the table, and in first half I need to write A, and in the second half I'm going to write B. And then in the next row of the table, so first we need to insert whatever the numbers we are going to deal with, and then we will follow the next steps as they are given in the step 2, 3, and 4, 5. Okay, so for example, let's create the multiplication. Let's do some numbers. Let's say 17 and I don't know, let's say 5. So in the under the A, we're going to write half of A and ignoring the remainders. Okay, so half of 17 would be 8.5, but we ignore the remainder. Then half of 5, not half, but the double of the B, so then I'm going to do 10. And then we will repeat the step 2 until we reach a row which has 1 in the left hand column. So this is 4 and 20, then this is 2 and 40, and this would be 1 and 80. Okay, and now step number 4 tells me I need to delete all rows where the numbers in the left hand side is even. That means left hand side is even here, here, here. And then at the end we need to find the sum of the non-deleted numbers in the right hand side. That means I'm looking for the sum of this number and this number. What is 85? And indeed 17 times 5 is 85. That means the algorithm does work. Okay, you can try now. Let's do one more, and you try on your own. Let's do 66 and 56. Okay, you can pause the video, try to do it, and then play on, and I will show you the answer and the numbers. So left hand side we're doing the half, so 33, 16, 8, 4, 2, and 1. This will be the last one, that's the signal I need to stop. And in the other one I need to double them, so 112, 224, then I have 448, 896, then I have 1792 and 3584. The step 4 tells me to delete everything that has even numbers on the left side. So this one is even, 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 and at the end I'm going to add the remaining parts in column B. That means this one and this one. And when you add 112 plus 3,584 would be equals to 3,696. And that is indeed correct, because you can take a calculator and 66 times 56 is 3,696. So with the algorithms given in words is not difficult. If your comprehension of English is good enough, then you will have no trouble, because you just follow the directions precisely. The second case that we're going to discuss are the algorithms given by flowchart. There is agreement that we are using this shape for start and ending comment or start and ending step of the algorithm. Then these are the instructions. We use the rectangles, and then rhombus we use for some decision. So for example, here you can see start and end in box 7 and box 1, and then there is one decision part in box 6, right? If you start with this one and you follow it precisely, in the A case it says implement this algorithm using a trace table. So again, what does the trace table say? Just go and read step by step what it says. So I'm going to try to do A case here. So what does it say? We have n when you read through the algorithm. Then we have another variable is e. And then we have the decision in box 6. So decision in box 6. And it says, it tells me n equals 0. Okay, so that's my first. Now the box number 3 or step number 3 says increase n by 1. So I increase it by 1, and then I have to assign the value to e is 2 times n. So in this case it's 2. And then I print it, that means I wrote it down. And the question is n greater or equal to 10? Well, if it's no, then I have to go back to repeat box 3 or instruction number 3 or step number 3. Okay, so this is no. And then you keep going. So I have to increase n. So 2 times 2 is 4, and again is not yet, n didn't reach 10. So 3, 6, and it's no. 4, 8, and a no. 5, 10, and a no. 6, 12, no. 7, 14, no. 8, 16, no. 9, 18, no. 10, 20, yes. So if it's yes, then it's stopped. And now you can ask yourself, okay, what's the product of this algorithm? What does it produce? Well, if you look at this, then this is your output, right? And the output is the multiples of number 2. Now, in the B case, it says if we alter box 4 to do the 3n. So in here, instead of 2n, I would have 3n there. Well, then obviously, if you're going to repeat the same one, then it will be, in the B case, the table would be the same, except the output would be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, so in this case it would be first 10 multiples of number 3. So the next question, when you look at this one, we can do one, we can do, for example, a case. It gives you the roots of quadratic equation. This is exactly what you do when you are solving it in mathematics. You have to find the discriminant first. If the discriminant is negative, then it has no real roots. If it's equals to 0, then we have equal roots. And then if it's not equals to 0, if it's not negative, that means it must be positive, and then you have root 1 and root 2. Okay, so if you would do this, then let's just do a case, okay? A case, I will solve it somewhere here. So first input A, B, C. So I need A, B, and C. So that would be, in this case, 6, minus 5, and minus 11. Then the next step tells me I need to find the D value. And the D value in this case would be 25 minus plus 66. No, B squared 25 minus 4AC, so sorry, 200, so 289. That would be the D. And then, oops, and then you go on to the next one. Is the smaller than 0? No. That means you keep going. Is it equals to 0? No. That means you keep going. And then because it's greater than 0, then you have x1 value. Well, when you find the x1, you will get 11 over 6. And when you find the x2, you get minus 1. The next algorithm that is kind of interesting is the Euclid's algorithm. He was a great mathematician who devised the algorithm for finding the highest common factor of two numbers. Highest common factor of two numbers is such number that it can divide both numbers, and it's the biggest one possible at the same time. So when we look at this, again, we have obviously the start and the beginning. Where is the stop? And how does that work? We need tracing table. That would be the best one if you can see it. So what's happening? We need to, example is to find out the highest common factor of 240 and 90. So I'll go step by step. It's highlighted by green, which step I'm doing now. So I'm inputting AB, that is 240 and 90. The next step is P will be the integer part of A divided by B. So when you divide 240 by 90, then the integer part is 2. You can forget the remainder. Then the next step is to assign to Q the value P times B. That means you're going to multiply these two. So that would be 180. And then you can move to the next one. R is A minus Q. That means 240 minus 180. That would be 60. And then you are asking yourself the question, is R equals to 0? Well, it's not. If that's no, that means the A, to the A value, I will assign the B one. That means 90 will become the A, and R, that means 60, will become the B. And then you repeat the same process. So to the P, 90 divided by 6 is 1. To the Q, you're going to write P times B. That means P times B is 60. To R, you're going to find out the difference of 90 and 60. That's 30. And again, it's not 0, so we repeat the same steps. Assign the new values for A and the new value for B and repeat the same steps. Integer part is 2, Q would be 60, and R would be 0, and that means r is equals to 0, yes. And if it's yes, that means I'm going to print. That means my outcome, b, is the value that is current in b. That means is 30. And if it's 30, that will give you the highest common factor of these two numbers, 240 and 90. That means it's the highest number possible that can divide both of the numbers given without the remainder. And it's the highest one, obviously. It might seem, okay, what's the point of this? Yeah, because obviously if I give you numbers like 240 and 90, you can even do it in your head. But then imagine if someone gives you these kind of numbers, like 7 million something and then 54 millions and something. So if you can teach the computer to repeat these steps, and computer is, you can teach the computer to evaluate if the remainder is 0 or not, and assign the new values and repeat the same steps until I will not get the yes there, that means I will not get r equals 0, it can save you a lot of time. So now, your turn. In this section, what we will do is, I will give you some example. I'm going to solve it, but I would like you to pause the video first and try to do it on your own, and then compare if you got it correctly or not. Okay? So you can pause the video and then come back to it in a moment. So, if you look at question 5, we need to copy and complete this table. I will use this table here. If I will need more lines, then I will continue down. Okay, I'm going to use the blue pen. So what do we have? In the algorithm, it says we need to input A and B. So in my case, it's 8 and 7. Question is A less than B? No. So if it's no, then I'm following this part. That means to A, I assign their difference. That means it would be 11 now. To B, I'm not changing anything. But it's still no. It's not less. 11 is not less than 7. That means I'm still repeating the same step here. So 11 minus 7 would be 4. 4 and 7. Now the answer would be yes. So if the answer is yes, it tells me to print a value. That's number 4. And then I need to stop. So when I finished in the B case, it tells me what is achieved by this flowchart. So you can try to think, or if you did try to think, if you look at number 8 and number 7, and what do you need to do with them in order to get number 4? Well, if you thought correctly, then this is the remainder after the division. Remainder after A is divided by B. C case says if A is k times B for some positive integer k, that means A would be k times B as a multiple, write down the output of the flowchart. Well, if you do know that it produced the remainder, and because A is a multiple of B, then you know multiple of B, and when you divide it, then you know the output would be equals to 0 because there is no remainder after you divide the multiple because it's completely divisible. So when we look at the next example, it's described by this flowchart, and what we need to do, the initial value of S is given 25,000, and you need to compile the table. So just follow the steps, input the S value, that's 25,000, and assign the T value equals 0. Then find out the R, what is S minus 8,000, what is 17,000. R is positive, that means it's okay, and that means I continue and I assign the new value to t, what is 20%. Then I continue and I assign the new value to r, what is 17 minus 10,000, 7,000. But r is still not positive. It's still positive. That means I can move on and I assign the new value to t, what is t plus 15% of r. And then I do the r minus 12,000, what gives me the negative value. And now in this case, I'm here, it's not positive. That means I'm following this path. I'm going down and I'm going here. That means I skip this step now. Okay, and because I am here now, that means I can print out the value of t, what is currently there. If this algorithm is designed to model a possible system of income tax that will tell you how much tax you need to pay based on your salary, okay, and then obviously because if someone earns 25,000, then the salary, the tax they're going to pay is 4,450 pounds. And the CK says, find the maximum annual salary of a person who pays no tax. So you have to think about it, and I think you did already. If the person pays no tax, then t must be equals to 0, and r is obviously less or equal to 0 then. Okay, because that's the value when the t must be printed. R must be negative or equals to 0. Okay, so what that would mean that s minus 8,000 must be less or equals to 0. What will give you s is less or equals to 8,000. So the maximum salary that will give you no tax, or the maximum salary that you're not going to pay tax on, is 8,000 pounds. So the next example that you can try refers to this flowchart. So you can pause the video, follow the step-by-step starting here, ending here, and then after you are finished, then you can play the video to see if you got it correctly. So if you try it, then obviously you know that the first step is to inputting the value that is given, that means number 90. Then the next one, I'm taking the first number in the list of p-values, what is number 2. I am dividing a divided by b to get c, and I'm asking and making the decision here if it's an integer. Yes, it is. That means I'm outputting the value of b that is currently at the b assigned to b, that number 2. Next decision I'm making if a is equals to b, and because it's not, then I'm following this path and I'm assigning to a the value c, what is 45. And then I'm going back to this point. I am assigning the first number in list b, what is 2. 45 divided by 2 is 22.5. It's not an integer. That means I am here now and I'm increasing. The next integer is number 3. So 45 and 3, when you divide, it's 15. It's an integer. That means I can output. But 15 and 45 are still not the 3 and 45 are still not the same. That means I'm assigning the new value, that's 15. 15 and then divided by 2 is 7.5, and so on. If you keep going, then you should get the final step is here when 5 and 5 are equal. That means I need to stop here because it says if a is equals to b, then I'm stopping, I'm ending. Now, what's the outcome of this algorithm? What does it produce? Well, it produces number 2, 3, 3, and 5. So when you think about that, 2 times 3 is 6, 6 times 3 is 18, 18 times 5 is 90. That means it gives you the prime factors of a, because 90 can be written as 2 times 3 times 3 times 5. And then the last one, write down the final value of c for any initial value of A? Well, obviously you know that any number you will do, then you will always get the last one will be the number 1. So now it would be your turn and you should self-practice. In the book there are a couple of problems that we haven't done yet. One is on page 5. Those are for the algorithms given in words. And on page 9, set 1b, are the algorithms given by flowchart. So please try now. You have the whole weekend to do that. And then Monday and Tuesday before our further math classes, or after our further math classes, I am going to stay in the school. I'm going to sit in my class and I will be happy if you come. If you didn't understand something and you want to clarify it, then obviously I can help you. Also, when you will follow the notebook of decision mathematics on OneNote, I will give you precisely the direction for every single lesson, including the notes, the link for the video, the PPT with the notes in it, and also the released problems. Once we finish, I will also give you the booklet of the released problems from past years. There is another thing what I want to mention. You can find out the answers at the end of the book, obviously, but if you want to see the full solutions, then you can go on this website and you will find every single set has the solutions there. So once again, guys, this is not the class where you can just copy something and think you will get by. Obviously, this is teaching you the responsibility. I'm gonna provide everything for you. I will allocate 2 days, 2 afternoons for you to clarify if you have some doubts, but you are the one who needs to do the work, okay? So please follow all the directions that I'm giving you, and I hope we will manage it together.